So molality is our second unit of concentration. Molality symbol is a lowercase, sort of a cursive or italicized M, but it's lowercase as opposed to molarity, which was a capital M. Okay, molarity is a capital M, molality is a lowercase cursive or italicized M. These are called molal solutions versus molarity, which we said were called molar, M-O-L-A-R, solutions. Now, molality's formula is calculated by taking the number of moles of your solute and dividing by the number of kilograms of the solvent. Now remember, molarity was moles of solute divided by the number of liters of solution. So let me just kind of compare these side by side. Moles per liter versus moles per kilogram. Moles per liter of solution as opposed to moles per kilograms of just the solvent. Now 9 times out of 10 your solvent is going to be water. That's our universal solvent, but it's not always going to be water. If from your context clues you can't tell directly what got dissolved in the solvent, then what you want to do is look at your relative amounts. Remember, your solvent is the substance that's always present in the greatest amount, and the solute is always the substance that's present in the least amount. Now, since this formula has a mass as the denominator, sometimes we might be given the volume of water instead of the mass of water, so we need to remember this relationship. This is only true for water, but this is something that we will use oftentimes with this formula if water is your solvent and you're not given the mass directly. You need to remember that 1 kilogram of water is equal to 1 liter of water, and a gram of water is the same as a milliliter of water. So this is something you want to make sure you remember, ostracize it, highlight it, commit it to memory because you're going to need it. All right, so let's look at some examples dealing with molality. These tend to be a little more challenging because if you'll notice here, both of these givens are in grams. And so you have to really use your context clues. So this says a solution contains 17.1 grams of sucrose dissolved in 125 grams of water. Now from that first sentence, you can tell the sucrose was dissolved in the water, which means the sucrose is the solute and the water is the solvent. Another thing I want to point out, look at your relative amounts, 17.1 grams versus 125 grams. The solute is always present in the lesser amount and the solvent in the greatest amount. And remember, that's also if you're comparing the same unit, gram to gram. So here it's easy to tell, but on some problems it might not be. This is calculate the molal concentration. Molal is the lowercase cursive m. Versus molar, it ends in an R for the big M. This is molal. So I'm going to write down my formula. Molality is equal to moles of the solute per kilograms of the solvent. So the solute is the sucrose. So we got to get the solute to moles, and we got to get the solvent to kilograms. Neither of them are in the proper unit right now, so we have to do some conversions before we can plug into our formula. So let's convert the sucrose, 17.1 grams of sucrose. Now this formula is C12H22O11. This is like regular table sugar that you would have in your home, Dixie crystals, if you will. Sugar cane. So we need to find the molar mass of this substance so that we can convert to moles. You got 12 carbons. You got 22 hydrogens and 11 oxygens. So I'm going to go ahead, if you'll pause the video and calculate it real quickly. I'm going to keep going on for time's sake because the video only lets me record 10 minutes. So I want to make sure I get all these examples in. So when you add the molar mass of this up, you get 342.34 grams per mole. This allows grams to cancel. When you divide by your molar mass for your moles of solute, you get 0.0500 moles. So there's the moles of the solute. And now we need to get the solvent in kilograms. So we got to use kids have dropped over, and we need to get it from grams to kilograms. So we're going to move from home base 1, 2, 3 places backwards. So up here, if you move your decimal 3 places backwards, 1, 2, 3, you're going to end up getting 0.125 kilograms of water. So now we're ready to plug into our formula. Plugging in moles of solute, 0.0500 moles divided by 0.125 kilograms. When you divide here, you're going to round to 3 sig figs because both the numerator and denominator have 3 significant figures. So your answer for number 1 is going to be 0.400 molal. And again, you could leave that mole per kilogram if you wanted to. All right, let's look at another example. Pause the video and you try this one. It's done very similar to the one we just finished. I'm going to keep on, as I said before, because I'm short of time. I'm going to be cut off if I don't. So we need moles of solute per kilograms of solvent. So let's calculate the molality. They want us to find the molality of a solution that's made up of 2.55 grams of acetone, again, dissolved in 200 grams of water. So the water is our solvent, and the acetone, fingernail polish remover, if you will, is the solute. So we got to convert the 2.55 grams of acetone, CH3,2CO. We got to convert that to moles. So we need his molar mass. And remember, when you're finding the molar mass of this 2 distributes in. So there's 2 carbons here, 6 hydrogens here, 1 carbon here, and 1 oxygen here. The molar mass of acetone, when you calculate that, is 58.09. Make sure that you get that for your molar mass class. Again, don't just take my word for it. Make sure that you can get that. So we're dividing here to get our moles. 0.0439. That's your moles. Now, the water is in grams. I got to convert it to kilograms. So I'm going to move my decimal backwards 1, 2, 3 places. So that's going to give me 0.200 kilograms. And keep your zeros because they are significant in the beginning. So now we can plug into our formula. The moles we got here, 0.0439 moles of our solute divided by 0.200 kilograms of our solvent. 3 sig figs here and 3 sig figs here mean that we need 3 significant figures in our answer. So when you plug it in your calculator, drum roll please, you should get 2.219 molal. And that's to 3 significant figures. All right, one more example. This is what mass in grams of methanol is required to prepare a 0.244 molal. Notice the funny little cursive M, italicized M. That's the molality they're giving us. Solution in 400 grams of water. So let's write our formula down. Molality is equal to moles of solute per kilograms of solvent. One more time. In this case, the solvent is the water and the molality is given. So the difference in this problem is they're giving us this number. So let's plug it in, 0.244 molal. So we're going to have to find the moles of our solute, and then when we find it, we're going to go to grams. The solvent